I'm Bernard Foing, the moderator of this session, and for those of you that arrived in advance, we had prepared a special surprise, a movie teaser before we start the panel.
The European Space Agency is working to take humans beyond low Earth orbit and deeper into the cosmos. Our next destination on this journey is the Moon. The 1960s and 70s were an incredible era for space exploration. The Ranger missions from the United States took close-up images of the Moon before eventually impacting the surface. NASA's Surveyor missions demonstrated a controlled soft landing at the surface of the Moon and tested the properties of lunar soil to prepare for future human missions. A series of Soviet landers and rovers visited a number of locations, performing scientific investigations, driving across the surface, and returning samples to Earth. But the pinnacle of this period of exploration was Apollo, and the arrival of humans at the surface of another solar system body for the first and only time in history. Looking back now, though, we see that only a tiny fraction of the Moon's surface has been explored, all on the side of the Moon that faces the Earth and in a region close to the equator. We've also discovered that all of the samples we have returned to Earth are from an unusual region with a complex and exotic chemistry of potassium, phosphor, and rare earth elements such as thorium. The vast majority of the Moon has yet to be explored, including the entire far side. One thing that we can say for certain is that if we want to understand the Moon, then we need to go back there. Now, after decades of waiting, an armada of missions from around the world, including ESA's Smart 1, have returned to explore the Moon from orbit. Looking down from above, these missions are providing a wealth of new data, bringing a new understanding and raising new questions. They are giving us a global insight and preparing for new missions to the surface led by China's Chang'e 3. And the next wave of missions to the surface? Where might they go? The next destination will be unlike anywhere we have been before, the extreme and alien landscape of the lunar South Pole. Here, we find areas of permanent darkness and extreme cold, where water ice and other chemicals can become trapped. And as we come up from these lowlands, we see towering peaks, basking in near constant light. On these polar mountains, the sun rarely sets below the horizon, providing the potential for near continuous solar power and a spectacular view over the rugged and cratered landscape below. In 2009, the L-Cross mission blasted water and other chemicals out of a permanently dark crater in the South Polar region, allowing it to be observed by nearby spacecraft for the very first time. We also now know that there are nearby locations with similar cold conditions. Is there water here too? If so, how much is there? Where did it come from? And what can it teach us about the origins of water and life-forming chemistry on Earth? This water may have been delivered by comets and asteroids impacting into the surface over billions of years. It may even have been created at the surface of the Moon. We now know that protons thrown out by the Sun in the solar wind arrive at the lunar surface. Here, they react with oxygen in minerals to create a thin layer of water. These water molecules can be lifted by the Sun's heat before falling again to the surface. Over time, these particles may move to the polar regions, where they are trapped by the cold conditions. And as we stand at the pole, with the Earth in view, we can point our antennas to the sky to search for faint signals from deep out in space. But radio noise from the Earth is too loud and blocks out many cosmic radio sources. But as we move over the horizon, the Earth sets out of view. the noise disappears and a new kind of radio sky emerges. We see our galaxy and the planets as never before. And beyond, a quiet radio hum, a signal from the cosmic dark ages more than 13 billion years ago, when the first cosmic structures were formed. And now, beneath us, the moon as we see it today, scarred by craters formed by billions of years of impacts, and the largest and the oldest of these, the South Pole Aitken Basin. Formed by a powerful impact around 4 billion years ago, many believe that its formation marks the start of a dramatic period of bombardment onto the Earth and the Moon, an era called the Cataclysm. This era is recorded on the Moon's scarred surface, and its end coincides with the appearance of the earliest observed traces of life on Earth. In the coming years, we will see explorers at the lunar poles, exploiting the extended sunlight for power and performing research to benefit life on Earth and to understand our place in the universe. This will begin with small robotic missions to understand the environment and prove new technologies to pave the way for the future. We will then move on to increasingly ambitious missions with humans and robots working together, learning to live and work at the surface and performing new and important scientific research. This new exploration will be achieved not in competition as in the past, but through peaceful, international cooperation. Eventually, we will see a sustained infrastructure for research and exploration, where humans will live and work for prolonged periods. Here, we will put into practice the lessons of years on the International Space Station to establish a facility akin to those that we see in Antarctica today. In the future, the Moon can become a place where the nations of the world can come together to understand our common origins, to build a common future, and to share a common journey beyond. A place where we can learn to move onwards into the solar system. And perhaps in the future, at a sun-bathed peak at the lunar South Pole, at the edge of a crater, we will learn to access and utilize resources from deep below in the dark. Zooming in, closer and closer, we see water ice molecules trapped in the cold. A source of hydrogen and oxygen, essential for sustaining human life and for rocket fuel. Fuel to propel us further into the solar system and on to the next destination of our journey into the cosmos.
Good morning. Welcome to the Moon. So, I'm Bernard Foing, and I'm the moderator of this session today, and I'm going to ask the different panel members to come on stage and take their seat. And we are starting a journey to the Moon. Please fasten your seatbelt, because we are going to have a travel full of discoveries, of science, of technology, of engagement, international cooperation, a journey for the youth, for a large public. So we have today with us a panel of guests. So I will start with Dr. Oleg Gorshkov. He's acting director for Transmash. We have Bill Gerstenmaier, so associate administrator of NASA. We have Peter Batenburg, who has been selected as a Young Lunar Explorers representative after a competition which was run by the Space Generation Advisory Council and the International Lunar Exploration Working Group. And we have Professor Jan Woerner, Director General of ESA. So let's give them a round of applause. So you see a bit how we are going to try to use this 1 hour. And so we'll have a series of introduction statements, and you can already start to ask questions. And we have a lady in orange there that can collect your question, and we'll bring them for the question and answer session. And I would like to start to give some introduction on the context, and also to represent some of the colleagues from other space agencies, from Asia in particular, that are present in the audience. But we would like to summarize what is happening, or what has happened in the last decade in lunar exploration. Indeed, we had an international lunar decade of orbiters, and we are preparing the next one, lunar decade of landers, towards international bases and towards a moon village. 12 years ago, we launched Smart One, first mission of ESA to the moon. And this is one iconic view where for the first time we could see the pole of the moon and even the far side. And we have studied with a fleet of other missions the moon, not only for itself, but also as a place where you can study processes that are shaping Earth-like planets. Volcanism, tectonics, bombardment, you can use it to date the history of the solar system, and we have also in particular studied the polar regions. We have merged this data with data obtained by previous explorers, Apollo, rovers, lunar samples, to make the link between the local moon we knew in a few places and the global moon. We have also mapped the next destination for us. This is a hitchhiking map you could use when you are going to settle on the moon, near the South Pole, where you have areas just at the edge of the far side where you see the Earth 2 weeks per month. And you have also beautiful places for geological studies or for searching for ices and other volatiles. So 20 years ago, we formed the International Lunar Exploration Working Group, a forum between community, space agencies, young lunar explorers at large, scientists, engineers, and we proposed a logical step approach for exploration, starting with the robotic precursors, orbiters for reconnaissance, then landers, then bigger landers to deploy infrastructures, and then the first human outpost leading to a sustainable lunar base, and eventually to moon village and moon cities. And so we have been working de facto with the different space agencies along this vision. And here I would like to summarize some highlights of what we have got from other countries, like the Japanese Selene Kaguya mission with a beautiful new topographic map of the moon, Lunar Reconnaissance Orbiter with a sharp vision, with half-meter resolution, where you could even see the traverses from previous Apollo mission and even artifacts there on the surface. Great science opportunities as well with this mission, which is still in operation. We had also an international mission, Chandrayaan-1, built by India with a strong contribution from ESA with 3 instruments, also with instruments from the US and other countries, which have made the confirmation of the presence of hydroxyl, so OH at the poles, and even a much larger area around the moon, and with a kind of breathing variation. Indeed, we have discovered water on the moon, water in the form of this hydroxyl in terms of ice mixed with the soil. We have also the US way. We have sent an impactor to the moon and analyzed the ejecta to show that in these areas there is 6% of ice mixed with the soil. Even now we have discovered that the moon is wetter than the Earth. The bulk of the moon, some samples have been reanalyzed, and we found some inclusion of water in lunar lava that makes it wetter in bulk than the Earth. a lot to discover, as you see. The moon is not bone dry. The moon is still rich of discoveries, teaching us about how our planet works, but also teaching us what we need to know for future exploration. The US also have developed a beautiful gravity mission, a tandem of two spacecraft that have delivered the best gravity map of the moon, where you can see in the center the far side of the moon, completely different from the near side. Also, our Chinese friends have developed a series of missions, Chang'e 1, also with the help of a European in the communicating with the spacecraft and downloading the data. And they also managed to get their prime minister to unveil the data from their missions. That's what we should also do from time to time. Chang'e 2, a big success, and also Chang'e 3, lander and rovers. So a very intensive decade. Now, the next decade, we see also new actors, commercial, Google Lunar Express, entrepreneurs that want also to reach the moon. We are conducting programs to train so the next generation to use instruments to prepare for future exploration. We do that in the laboratory, we do that in the field. We have conducted such campaigns. We are doing also isolation studies where we put crew isolated in the middle of the desert like they would be on a moon base or Mars base. And we have realized during all this mission from all these countries that there is the moon is such a powerful vehicle to inspire the next generation. And we started at ESA, very inspired by Professor Woerner's Moon Village vision, a series of sessions. We call them jam sessions, where we work on getting ideas, concepts, engaging the youth. So this is one session we had at ESTEC. We ran 2 sessions there. We ran 1 session at the European Astronaut Center. We even ran a session during an art festival where we collected also the views from artists about the Moon Village. Also, we brought the moon to the public. We observed the total lunar eclipse from different places around the world. This is from Montmartre, where we could get all the public gathered and shared our wish to explore the moon. Now, from the ESA side, we have also conducted a number of studies, like studies of how you could use 3D printing techniques to build artifacts or even habitats. And from our experience in the exploration of the solar system, okay, we have done smart one. We want also to use our development in telerobotics for the next generation, where we have robots and instruments teleoperated from Earth, but even from lunar orbit. And we are looking at a collaboration with our Russian colleagues in their mission Luna 27, which is a polar lunar lander, where we look at sites, we looked at communication, we looked at scientific instruments that we could provide. And also we have a strong partnership with NASA in the Orion and the service module that is going to be brought to the moon and back. We even started some exercise to look from the previous data that we have obtained. Can we start planning the traverses around the poles that with rovers teleoperated from orbit? And before, we even made some joint studies how we could put various elements for building up this first moon outpost. So we tried to be inspired by also the recommendation from the scientific community. For instance, COSPAR Planetary Exploration Panel has issued a report, and we tried to look at all these ingredients that help us to get also a good science technical foundation in future exploration. So that's, in short, the introduction, giving the context before now going to ask our panelists to make a statement. So we have asked them a 4-minute statement. In the meantime, you can start to ask questions. So I would like to ask from the most remote and distinguished panelist from America. So Bill Gerstenmaier to start. Thank you.
Okay, thank you very much. As you can see from both the movie and from Bernard's introduction, NASA's made a long investment in lunar exploration, and it pays off in many ways today. You got to see the Lunar Reconnaissance Orbiter images on the screen. That was launched in 2009, and it's in its third extended mission and continues to function beautifully. The integrated data sets that LRO has represents big advances in our understanding of the moon's history and geology, as well as an improved understanding of the regoliths and the interaction of the sun on the airless surfaces and their interaction with volatiles. Also, as you saw again in the videos and also in his remarks, LCROSS demonstrated the presence of significant water ice concentrations at the lunar poles that could be really critical to future exploration activities as we move forward. You've seen the images of both Grail and Laddie. Laddie was a very good mission for us. It really debunked the notion that the tsunamis of elevated dust around the terminators that were suggested from the observations by the Apollo 17 astronauts were really not there, and Laddie did a great job with that. Laddie also has provided a lot of data that will help us better understand the volatile cycles on the moon. Again, as described in the opening remarks, the interaction of the solar wind with the surface of the moon and the airless body tends to trap particles in various locations, and Laddie is giving us a lot of insight into those areas and that transport model. You know, Laddie also carried with it a unique instrument, Lunar Laser Comm. We were able to actually communicate with a laser device at 600 megabits per second from the vicinity of the moon, and we learned how to operationally use the laser communications around the moon, and that was very interesting to us. We were able to receive data in full sunlight on the Earth. We were also able to receive data when the moon was essentially full. We looked at acquisition times out of the instrument, so we really understand now how we can provide a high-link data connection back to the Earth from the moon. Grail, as was seen in the picture, really helps us understand not so much the details of the surface, but more about the gravity of the moon, which will ultimately help us as we take future missions to the moon. We also have a lot of interest in lunar volatiles. The resource prospector is intended to investigate how volatiles such as water are entrained in the lunar regolith, and the resource prospector will be an international partnership to go, if it's going to go forward, and we've been working with JAXA on developing a very capable lunar lander. I think it's important we know the volatiles are there on the surface, but we don't know exactly how they're captured in the regolith. It will be important for us to know with some kind of surface sampling to actually go in and understand, can we get those volatiles out and use those? The NASA Catalyst Project's a collaborative effort between NASA and industry. We're trying to use everyone's expertise to get there and again understand volatiles and how we can potentially use them in the future. As we look forward towards Mars, if we can get resources off the moon, the oxygen and hydrogen, that can be a tremendous change in the way we would do Mars-class missions if those volatiles are available to us and we can pull those off the surface. So we have several investigations aimed in that direction. And then lastly, I would say that we're also looking at some creative ways to get data. We have on the Exploration Mission 1 in 2018, with the SLS and Orion spacecraft, we'll carry 2 CubeSats with us to the vicinity of the moon, Lunar Flashlight and Lunar Polar Hydrogen Mapper. And both of those CubeSats are, again, to gain some more insight into the volatiles on the surface of the moon and understand the surface of the moon. It's exciting to see the technology that's being driven by those CubeSats as we shrink command and data systems and we shrink sensors to be small enough to fit into a CubeSat to provide data to us. And we're leveraging off of the Exploration Mission 1 to get those CubeSats in the vicinity of the moon. So with that, I think that's enough opening remarks, and I look forward to your questions.
Okay, thank you. Very impressive lunar program, as you can see. I don't know what the media reported, but they didn't realize that you had such an inventory of scientific and technical mission to the moon. So we should also stress what you have done. Now, I would like now to ask Dr. Oleg Gorshkov, the acting director of Transmash, more to discuss your perspectives in lunar exploration. Thank you.
Thank you. So, dear colleagues, good afternoon. I would like to share with you our vision of the space exploration program, which focused on the moon and which is a part of our new Russian federal space program. Today, the program is in process of governmental approval, and till the end of this year, the program should be accepted. So, in accordance with the upcoming Russian Federal Space Program, the space exploration program, which is a moon exploration program, will go through the following three directions. The first direction connects with ISS activity and post-ISS activity. The second one is lunar robotic exploration, and the third one is the preparation of lunar human missions. So it connects for the first direction of our activity for the moon exploration. I can say that at the moment we consider the ISS as a test facility for maturing of the advanced technologies for the future robotic and human missions to moon. At the moment, we have a plan to use ISS till 2024, and as a part of our post-ISS activity, we are going to develop the Russian orbital station as a prototype of prospective lunar orbital infrastructure. So this connects for the second direction of our activity for moon exploration. It means lunar robotic missions. We focused on the selection of the area for a future moon village, and we are going to launch at least 3 spacecraft to moon, robotic spacecraft, and 2 of them for a lunar surface, as another one of them for lunar orbit. And this connects for the third direction of our activity, which is preparation of lunar human missions. I would like to say that we are going to develop some main elements of space transportation system and some elements of lunar surface and orbital infrastructure. First of all, I mean the development of new crewed spaceship, and we are going to have a first test of a new crewed spaceship in 2021, and it should be unmanned flight to low Earth orbit. And the first manned flight we are going to do in 2024. It should be a flight to ISS, and I hope that we will be ready to organize the flight of this new spaceship to around the moon in 2025. And as a conclusion of my brief speech, I'd like to emphasize that our space exploration program is fully open for international cooperation, and I think that we have a very brilliant example of international cooperation. I mean, ISS activity. On the basis of this, on this example, we can create. I hope that we can do it. We can create international space exploration program with taking into account the interests of many countries. Thank you.
Thank you. So, please can you put the previous presentation, actually the slide from Dr. Batenburg are in the previous presentation, the one which I just started. And the last speaker will be Professor Woerner. So, yeah, excellent, yes. Yeah, so our next speaker has been selected after a competition process which was run by our friend from the Space Generation Advisory Council and with the support of the International Lunar Exploration Working Group. And Peter Batenburg is a winner. So, and he has also, yeah. He has made also so there are some clips they have produced, some essay, and also they have made a special effort to attend some of the sessions and to talk to the other young lunar explorers all over the world. Peter.
All right. Well, first of all, my thanks to the ILEWG and Space Generation Advisory Council for giving me this chance. What I've did is collected inputs that I've seen in presentation this week, thoughts of my own, but most importantly, ideas and wishes of fellow young professionals and students that I gathered this week. So I'm going to briefly go through the first bit because I think most of it has been highlighted already, and particularly in the video. When it comes to the moon, some people might say, been there, done that, let's move on. I would say, been there, done quite some bit, but we're still not there yet. So let's pick up where we left. The lunar South Pole is proving to be a very interesting area, full with enigmas. Most importantly, starting to better understand the moon will help better understand the history of our planet. But due to the similarities of surface cratering will also help us better understand many of the other objects that we find in the solar system. I actually got the controller here, so that, thank you, Mr. Woerner, for that. So like I said, we've been there just a fraction, and we stayed in a relative safe environment, and the video showed that quite well. We stayed on a flat surface, we didn't go too far, we didn't go underground, and we stayed for a short bit, even for robotics. And then there is the big issue of the big desire to use the in-situ resources. So that's, I think, where we still have a lot ahead of us to see how we can utilize that in not a lunar exploration, but exploration through the whole solar system. A couple of challenges, I think, which are the major drivers for building up knowledge, know-how, and technology for proper deep space exploration is large surface area exploration. It's nice to observe the surface from orbit, but there's only so much you can do. The video showed it. You need to go on to the surface and detect it. But if you're only going to a very small fraction, you have a statistical chance that you do not get the proper picture. So you would need to have a larger surface area to get the complete picture. Human-robotic cooperation has been addressed, and then the subsurface imaging, drilling, excavation if you want to use it also for in-situ resources. And prepare for human exploration. Mars is a long way and a long distance, and I know that many of you have seen The Martian. And I think it's in everyone's interest to know what we're going to do when we go out there to prevent it from happening and know what we can do and what we can do best. Then the most important bit, what are the people that I'm representing here today? Because I'm not sitting here as Peter, I'm sitting here on behalf of, I think, a few hundred people that are largely represented here in this room. What we are looking for is opportunities to contribute, to have a role in that lunar exploration and further exploration. Turn those enthusiasm and studies that we do at the university into reality and to contributions to an actual program, to actually go out there. And when doing that, have the opportunities to grow intellectually and also professionally towards a future in an exploration program. Something in the short term, I think this is maybe one of the biggest challenges that we're facing, that if the ISS, which is a huge inspirational program so far for young generation students and the general public, if that stops at a certain point in the near future, what are we going to do next? And that you would need to have something that the public can be interested in and students and young generation can be interested in. And for that, and I'm very pleased to see on so many programs, I've seen the NASA program, the ESA program, and the Russian program, and also the other agencies, the Chinese, Japanese, that they are speeding up their programs for a committed program on lunar exploration. We can do a lot, and my main message would be is continue with what the ISS offers today. In light what Mr. Woerner said earlier this week, as one of the two is access to orbit, I would say make it also access to the moon, so that anyone, universities, institutes, but also the public, can fly their own hardware at their own expenses or with a funded program, that they can actually get to the moon and do the science. And I think the way we see it now for the ISS and for other programs and the CubeSats, once the infrastructure is there, institutes, students, universities and industry, they will go, they will work with it. And work that out as a step-by-step process, as the video that Bernard showed you at the beginning has indicated. I think this is one of the jam sessions that we have, so you can see how many people from our generation are showing up, wanting to contribute to it. And it will be so nice to see that all those nice ideas that are also presented here this week could become actual contributions to an exploration program, be it on the moon, be it to Mars, but most definitely a general exploration program development. I think if we set up an infrastructure, a program, as Mr. Woerner said before, not an individual mission, but a program of rapid access to orbit, to the moon, you will see universities flying CubeSats. I know that my university of Delft has, for instance, interest in it, and I think there's a lot more of them. If you are doing a program towards the moon, industry will follow and say, hey, that's business. I can do something with that. We've seen that with SpaceX and Orbital using that for the ISS. And if you have such a program, then on a low scale, but with an exciting program, young generation can contribute with their own projects on the ones. And I think this is illustrated, and I see you guys right over there, and on multiple occasions, the panelists from last Tuesday on the ISS payloads. Those were exciting stories those people were telling. The young professionals getting an opportunity to do their own thing, to do their own payload and fly to the ISS. Now, wouldn't that be great if a future program would allow young professionals to do that on the moon as well? And then involvement of the public. Public is highly involved with human spaceflight today. And they were highly enthusiastic about the Rosetta mission, for instance. But if we would even go one step further and combine it, we have talks with astronauts in space. But how about, one of the ideas I heard is high school competition, and in the end, you can control, as a high school, your own rover and do a sampling of a rock that you detected. How about that? Now that, I think, would stimulate a lot the interest in STEM of a lot of students and the even younger generation. How? I think I addressed most of it. Build infrastructure, another mission. Work on standard interfaces that was highlighted by, I think, several agencies this week. Make sure that you can attach payloads at a later stage, that you make a platform like the ISS today with drawers. And make it open for different agencies to compute and industry to contribute as it, and make a global program, not only between agencies, but between the various partners, institute, universities, industries, and agencies together to build up expertise and continue that what we have today for the ISS and go into the solar system. And I think that's my... yes, of course, of course. So that would be the inputs, what I think are looking for. I think these workshops have already taken place, and these will be continued next year, where I think students and young professionals can be involved on working out those plans for the great exploration of the solar system.
Thank you very much, Peter. Wow. So, wow, great, yes, great demands from the young lunar explorers. Are we going to meet those? Of course, we need also your help. So we have a presentation now by Professor Jan Woerner.
Okay.
Yes, you can.
Thank you very much. And after the young generation, now the old generation is talking. But I'm very pleased that I have the opportunity to talk a little bit about Moon Village, especially Moon Village, because I think what all the contributions were already about is that we have to go more concrete. We have now, it's time not to talk just, but really to go ahead. But if you want to go ahead, from my point of view, what is very important, we have to convince people, we have to ask people to contribute. So as Bernard was saying earlier, so you are also, don't sit in your seat like in a cinema and wait what is presented for you, but be active. Try to communicate with us, because that's what we need here today, but also later on we need contributions from citizens, from politicians, in order to have at the end of the day a common program. And the question was raised already. The question is obvious, what's next? One could say that's not the right question. The right question should be something there, because it's not automatically that we do something after ISS. But ISS did a marvelous job by combining different nations and also with the European Space Agency, in addition, some more member states, to put together it on one platform. There were also some disadvantages with ISS. That was the limited access. So you needed to have either on the American or the Russian side, you need the spacecraft to go there, and also you had to be part of the game. That was the situation with ISS. So therefore, what I would like to do is to do it in a very general sense. At the very beginning, we have to talk about the goals, the demands, the requirements. And only if we have them, we should go to the next one, to look to scenarios, what can be done, what is most reasonable, and what are possible alternatives. If we have some ideas about that, and you heard already some, then the next logic step is to think about the consequences, not only the financial consequences, but for instance, do we need really an intergovernmental agreement? Do we need it or don't we need it? That's depending. In a village, usually you don't have an agreement, because all of the citizens of the village, they are just part of the village. And then you can have a proposal, and if you have a proposal, you, we, whoever can decide upon it. So this is the logic behind it. Now, I wrote down my goals, my requirements. Maybe you have different ones, and that would be very important to listen and to hear also your requirements and also requirements of the citizens. These are the requirements I found out. It should be open for human and robotic. We need a microgravity lab for the future. We don't have anything like that after ISS. We need the possibility for fundamental research possibilities, but also science and development. We should have international activities. It should be a proving ground for future deep space travels. It should be something like a springboard or stepping stone, however you call it. It should have an independent access for different actors. This is very important, as in a village. In a village, you can come on your own, with your own car, with your bicycle, or whatever you use as a transport media. You can go there on your own. And this is, for me, important for the future of international cooperation in that field. And it should be more than just a single mission, just to go to one place and go back. This is, for the future, not convincing to the public, not convincing to the taxpayer, not convincing to the governments. And it should be multi-purpose, and therefore I also call it Space 4.0, meaning introducing also public as well as private money. So when I looked into all of this list and how to fulfill them, my conclusion was just one proposal is not enough. So I thought to put two proposals on the table. One is frequent Earth orbit activities, especially for the micro-G experiments, and one is for the international exploration activity. Now, today we are talking here only about Moon Village and the Moon. Therefore, I will concentrate on that. But again, if you do global cooperation, don't try that all have identical opinions. Diversity of countries, diversity of cultures, diversity of competencies is a very big value, and we should try to combine them. I will give you some examples. So for instance, with the competencies, there might be countries are very strong in robots, others are in human transportation. Other countries may have a very special heritage in science, or in telerobotics, or in technology development, whatever there is. You see the list is open. And at the same time, if you communicate, and if you're asking for the request, what is necessary, also the countries might be different. So there might be one country saying, science, this is the one and only I would like to look to. And if this nation would then say, we make a scientific mission to moon, maybe some others will not participate. Therefore, we should take the diversity again as an opportunity. For instance, industrial policy might be very interesting for one or the other country. The direct benefits for citizens, the outreach, inspiration for young people, or it's just a question of pioneering. This is different from country to country, and you don't have to judge whether it's positive or negative. We should combine it to come to some global cooperation. And therefore, cooperation must be based on synergies, taking into account the diversity. This is, for me, the crucial point. Now, if I give only these two view graphs with the requirements and this very generic one, everybody would say, I agree, but how the hell can it be done? And so I gave a proposal. One is the frequent Earth orbit axis. I said, okay, for instance, let's use a European launcher. This is, of course, fine for us. Let's use, for instance, a spacecraft from the United States or from elsewhere, put it on the launcher, and then we can go to the Earth orbit. We can do micro-G experiments, as in the right up picture. We can do robotic deorbit of satellites, or even we can play with lasers to destroy small particles of debris, because this is a very global endeavor. But this is not the discussion today. Today the discussion is about the Moon Village. And the Moon Village fits perfectly in the project United States of America have right now, where Europe is participating with the European Service Module for the next big and deep space launcher, the Orion and SLS combination. And therefore, the proposal is just to fill all these requirements in addition to the Earth orbit with a permanent international moon station. So it's, as one can say, part of a journey, ISS, Moon, Mars, and beyond. So when you heard this week that some were arguing for Mars, some for Moon, some for this and that, this is ridiculous. We have to define the journey. The journey is the most important thing, and therefore the Moon is, for me, and also for our American friends, as I understood, a very logic point on that journey. And the Mars is then also something which is a little bit more beyond, a little bit, but okay, we'll see. So therefore, the permanent international moon station, you see on the left-hand side all the fulfillments of requirements. You see it's exploration, it's human and robotic, it's moon science, it's cosmology and astronomy, as you saw in the movie at the beginning. It's fundamental research, it's about transportation, resource management. Bill Gerstenmaier mentioned it also, to use hydrogen and oxygen for future use. There are companies interested in mining on the moon, why not? Communication, technology, pioneering, proving ground. It's really a proving ground, and there should be public as well as private involvement. There are companies they have the idea to have a hotel on the moon. Why not? There were some people sending me some emails asking for being the mayor of that moon village, and this was a little bit of misunderstanding. What I would like to say again is, this moon village is not consisting of some private houses, a church, a city hall, and a tennis court. No, the idea of village is to combine very different ideas, be it on institutional, on private, or on public side, robotic or human, so to combine all of this and come out then with a common ground where we can use it, very open, and also if somebody is looking for tourism, it's maybe, but outreach for sure will be done. So what I say is, it's free and open access, multiple users and multiple users, and therefore I called it Moon Village. And of course, it's very important that we are together very happy with that. So, but what is necessary is that we don't stop at that point. If somebody of you have a better idea, then don't fight. Just put it on the table, and as Voltaire was already saying some years ago, the perfect is the enemy of the good. And I'm ready to shift all my ideas if there is a better idea coming from some other person. So thank you very much, and I hope now that you will be now active, because that's the time to get the reaction.
Thank you very much, Professor Woerner. So let's go, because we have 20 minutes, a lot of short questions, more coming. So first one, do you think that in the years ahead, many missions will be private to the moon rather than agency funded? A question for Bill.
Yeah, I think kind of as Jan talked a little bit, I think first of all, the government needs to kind of go first and prove the way and show some of the resources that are there and understand what's available on the moon. And then after that is understood a little bit, then I think we need to step back and work with private industry and look for public-private partnerships to go do the moon. So I think there's a natural relationship where those first things, those first discovery kind of things are best done by the government, and then once those are done by the government, it's ready for the private sector to come in, and we need to be thinking about that from a government standpoint when we put our processes and plans together at the beginning, because we need to think that the end goal is really going to be a public-private partnership to utilize the resources that potentially are available there.
Okay, a follow-up question by Kyle. But what can space agencies do to encourage this commercial involvement?
So our task is, of course, I hope it's working. Yeah. Our task is, of course, to look for ideas, to promote ideas, to get the funding then available for it. So it's a big variety of activities, and then of course also to organize, if public money is directly involved, as Bill was saying, then to organize and administrate the money in the right direction. But my position, my personal position is that agencies in this new world have a very important point to be the enablers of ideas, meaning to discuss, to listen, first to listen, then to discuss, then to decide. So that is very important.
Okay, another question a bit, can you comment, exploiting the moon for profit, commercial mining, etc. Is that a good idea or a bad idea?
So that's
Peter,
it.
Let's get Peter.
Okay, Peter.
I'll keep it short and then you can comment on it. I think it's not an either-or scenario. Talking about a moon village, whenever you do a construction or some sorts in your town, there is always a way to make sure that you can do some archaeological research first and then do the construction. I don't think that it's going to be different in such a program. So
like preserving some areas for scientific research, like Antarctica, you do, and other for exploitation? Or?
Yeah, so those areas which are identified as highly scientific, preserve them. But once you're done with an area and you said, I am confident that I know enough from this area, why not? Let's go mining. I mean, if that operates business, it will keep the whole program growing.
Yes, I would never say no to business in space. That would be stupid. I mean, we are opening the space right now since several years, and it's fine. You might be right that we need some rules for it, but for instance, tourism on the moon, why not? If somebody is really doing that, or other activities, if there is a market, it will come anyhow. What we have to preserve is, what I mentioned at a different time, is the seamless chain of innovation. So we need fundamental research in the future, we need the market, the public use of space, and we have to make sure as space agencies that this seamless chain of innovation is remaining, because if we are losing the fundamental research or the gap between fundamental and applied research, we are losing this seamless chain, and this should not happen. So therefore, yes to private investment, yes to business out of space.
Can you agree on that? Yeah. Okay, I have another question for Dr. Gorshkov. So what do you consider more difficult to overcome? Political barriers, cooperation, funding, or technological issues to achieve the prolonged human presence on the moon? And how can we overcome them? Question from Volker. Yeah.
So I think that the most critical, of course, budget limitations as comparing with technical issues. My point is that for moon exploration, this connects with the technical issues we have, and our colleagues from other agencies have the approach to solve these problems. And my point, I can repeat that the main the most critical issues to do it, it's budget limitations and how we can over these problems. I think that one of the way maybe single way to do it, it's like international cooperation, because I can repeat that when we do together the international moon exploration program, we can to do together, and our budget can be not so critical for any countries, for some one country. So I can repeat that the most critical issue is political, it's a budget, and we can over this problem just through the way of international cooperation.
Okay, very
Maybe
good.
I can add a quotation. It's not identical, not 100%, but Werner von Braun was saying, when we tried to fly to the moon, we had to overcome two problems. One was gravity, and the other one was paperwork. Gravity we achieved rather easily.
Yeah, indeed. But we can build, we can build with paper. So I have a question now, interesting, from Miss Lei Yuan Li, who has been working on a lunar palace. This is from Beijing University, directed to me and to Bill Gerstenmaier. What type of life support system could be developed, and what are the technologies for life support that need to be tested before?
In terms of life support systems, we're doing a lot of testing on board space station today, but we really need a more reliable system than we have. I think the amount of closed loop system we have on station is about 86% closed loop on the water system. That might be sufficient for Mars on its own, but what we need is a much more reliable, robust system. And then as we discuss things here, if we can get resources along the way, like we can get potentially oxygen from the moon and it's in some readily available resource, we can use that oxygen again to augment some of our life support systems moving forward. Same when we get to Mars, it'll be clear that we're going to have to understand what we can use in the resources in Mars. So it's going to be very important for us to learn to use resources throughout the solar system as we make this journey. And I think that's one of the key investigations we want to do very soon with rovers and potentially some robotic activity on the moon to maybe actually do some drilling activities to see if we can understand how the volatiles are actually held in the surface. The orbiting spacecraft are great. They've given us a lot of good data, but I think as some of the panelists have talked about and Peter's talked about, we really need to get to the surface and understand what's really there and how it's bound in the regolith, and then that will play a key role in life support.
Good. So actually, we need to get to the surface and use the resources. That leads to the next question from Haim, from Rutgers University. I applaud the focus on the moon. Studies show that in-situ resource utilization on the South Pole may require costly and complex infrastructure. So, should the man return to the moon start at the pole or at another location? Is that the easiest location to start?
For me, it would be not the central question. Central question would be for me, and is for me, that we are starting now on an international scale to say, yes, we want to make this step. Moon as one step of the journey, again, that's important for me. And then we can decide the location, and then we should not wait until we have a full set, again, what was necessary, of course, with ISS. We can put together the different aspects, as I said first. A village starts with the first house. Again, house being a little bit virtual. Huh?
Good. Actually, I made some work on the moon, as I was leading Smart One. And I believe the pole is an easy location. You know, on the equator, you go from minus 170 degrees at night to plus 120 degrees during the day. While the pole is such a nice, comfortable temperature of just minus 30 degrees. I think some of you may have experienced that. So thermally, it's easier. You have volatiles at proximity. You have places with permanent sunlight. So it's a good site. And I would invest in real estate there. Maybe we should let the market decide what are the good spots to explore.
Exactly.
So now there was a question, another question about putting a big radio telescope on the far side, which is isolated from terrestrial interference. So anybody has a statement on that? Yeah, Bill?
We've looked at some studies where we could use potentially an orbiting Orion spacecraft, maybe with a habitation module, and we could actually deploy elements of a radio telescope on the far side of the moon. In fact, we've done that both in the US and in Europe. We've commanded rovers on the Earth from space station, and we've deployed a surrogate antenna, essentially a mylar antenna that we could lay out for hundreds of meters across some surface in California. ESA's done a very similar thing where they've commanded a rover from on board space station and looked at rolling out potential a large radio telescope on the far side of the moon. So rather than actually maybe building a telescope there per se, we actually use the surface of the moon as the infrastructure that holds up the arrays of the telescope, and then use the blocking of the moon to be the to shield the radio telescope from.
We made also some studies of deploying even some precursor dipoles, and I think very close to the pole, because the pole is almost the far side. 2 weeks per month, you are in the far side. You could just be shielded by some peaks and already make measurements. I have a question now, maybe for Dr. Gorshkov. Could, from Barak, a student from here, can we use existing equipment from previous mission, for example, rover from Apollo or Lunar Volatiles? In future missions, should we use some of the artifacts that we had in place before?
So we have experience for the moon exploration before, and of course we have some results from another missions to research a lunar surface. We think that the next step for the exploration should be connected with the research and investigation of concrete zone in the moon, I mean South Pole, for instance. And up to the moment, we haven't detailed information about some pole surfaces, I mean, for instance, South Pole. And this connection, our missions, which should be robotic missions, first of all, aimed to study a concrete point in the lunar surface. And I think that it should be new results for the lunar.
Okay, and I think also in the Moon Village, you could have some garage facility where you go and fix some of the previous artifacts. Now, I have a question from
I would like to have the cars.
You have the
New
cars.
batteries for the cars, and then make it.
I have a question from Henning, PhD candidate in Stanford. What construction technologies are important or do you think are necessary for building the lunar village? Is there a civil engineer here on the panel?
An engineer?
Oh, yeah. What construction technologies to...
That's me.
Okay.
Yes.
Jan?
So it's not that difficult. Huh? We have regolith, and if you consider what concrete is you use some gravel and you need a binding material, usually cement and water. Huh? That's all. So you are in a very favorable situation on Moon. You have already the gravel, which is about 70%, 80% of concrete. So just you need the binding material, and there are some smart ideas. Either plastic material. You can use, even because it's so cold in the dark, and if you go to dark sites, not to far side, but dark sites, you can even use water as a binding material. Water and regolith is already a very tough construction material. So there are enough ideas. I'm ready.
Very good. Yes,
There was actually one presentation I saw this week, and maybe it might be from the one asking the questions. It was a very exciting one of burning lunar bricks. I think those studies are already on the way. So once we actually are on the surface and we start in the small ones, we can start testing those technologies in situ and see if we can build lunar bricks, either with ice or with the magnesium burning process. And let's see what we can build.
Aluminum, yeah. Okay, good. I have a question, and then we'll have a wrap-up of 30 seconds per panelist. NASA is currently focused on Mars as a destination, with cislunar space as a proving ground. Can you discuss how NASA's proving ground operation, will relate to the scientific exploration of the moon by Americans or others?
Yeah, again, I think if you look in our document, the Journey to Mars document, we talk about the region around the moon as being a very important region for us. As I described to you, if we can understand there's volatiles available on the surface of the moon that we can use, that dramatically changes how we would build our architecture to go to Mars. We also see the vicinity of the moon as a very interesting potential transportation node or point to take off to go to Mars. So understanding the gravity of the moon and understanding how we can use gravity assist from both the Earth and the moon to essentially return from Mars-class missions will also be very interesting. So instead of maybe returning directly to the surface of the Earth with a human mission from Mars, we may actually swing past the Earth, swing past the moon multiple times and drop into a lunar orbit, and then actually return from the lunar orbit to the surface of the Earth. So we see the investigations of understanding what's available at the moon as kind of a first step in this journey. And it's what we can do is we'll work internationally and we'll work with companies as we move forward to figure out what's available, figure out the best way to do things, and then put together more of the plan as we move towards Mars. So we see the moon as really not something that's different. Again, I think as Jan said at the very beginning, it's really space station, moon, and Mars as a continuum, and we're really moving human presence into the solar system. And how do we do that in a logical way that takes advantages of all the resources and all the interests of the countries and investigators around the world as we move forward?
Okay, very good. Yeah, well, our time is almost up and we have to go for a launch because we need to do some work. So I will ask our panelists to have a wrap-up statement. So we start with Oleg.
So, dear colleagues, I think that we all understand that the moon exploration should be the step for the deep space exploration, for instance, Mars journey and something else. So we should do the first step for the deep space exploration, which is moon exploration. Thank you.
Again, I think as we look forward to moving human presence into the solar system and we go around the vicinity of the moon, we need to look to where the uniqueness of having the human in that vicinity can really add to the results coming back. If it's either in sample return or it's in low latency driving of rovers, maybe it's investigations of actually driving rovers into lava tubes on the moon or other activities. Wherever the humans can really benefit in that role, we want to do that as we head towards Mars and continue to move forward. So again, I think it's a pretty exciting time as we start to put together all these ideas. And I think as Jan said, we need to be careful we don't try to find the perfect plan through all this. If we get a good enough plan that we can get started and make real progress, I think it'll become obvious to us what next steps to take and to move forward.
Good. Peter?
Well, I can speak a bit personally, and I hope it reflects many of the young professionals here. I think this week has been very exciting to see how many ideas, how many programs are actually being developed, and I'm getting confident again that we actually will go out there. And then my request would be to my fellow panelists to create momentum for that, but also for all the young professionals, everyone here in the public. You've seen what the plans are. Let's carry that message out that we are ready to go and get the public going to support us, and let's go to the moon.
Jan?
Yes, so for me it's very important, as I said in my statement, that we take advantage of the different competencies of the different spacefaring nations and the different people in these nations, as well as we have to take into account that the different member states or the different participating states in the future in such an activity of a journey, that they can put their interest into the project, meaning not only the interest of the space agencies, but as well as the interest of the normal taxpayer, because we have to see whether they would like to have that, what we are proposing. It's not that we can decide only. We have in Europe right now other problems with migration and so on, so it's not the right time to say just let's send some people to some planet or moons. So therefore we carefully should think about the goals. We then should carefully put the communication on the table, but I'm ready to discuss it as soon as possible with all possible stake and shareholders, so that we can have a plan which is then realized stepwise in the next, let's say, 10 to 15 years.
Good. So we had a competition to select Peter as a plenary participant. We also run a competition with essay, and I think we have the winner, Kyle, among us. Yeah? Yeah, Kyle is there. So he has produced also a beautiful, why don't you come on stage? Yeah, Kyle. And we will try to do that in the future to get some more involvement for the youth. We are going to have some follow-up workshop. So we hold some in Europe. Could you help us some in your continent? Yes, and also in Russia. Now, I want to thank very much the panel participants and also all the audience. I think we broke the record of the number of questions that were addressed in a panel. We did better than the astronaut panel this morning. And I want to finish with one question. Who is ready to start supporting the Moon Village?
Okay.
From this lunar orbit.
More than 100%.
Okay, so thank you very much. And so, okay, we go to the technical session now. It was great. This Moon Village debate has started already at the head of agencies. We discussed it the whole week. I think something is happening, and we are all taking part of it. Thank you very much.